Good morning. I'm Robert Hall, and I'm the Executive Director of Resilience First, and it's my pleasure to welcome you to this Resilience First webinar held in partnership with Intel. By way of introduction, Resilience First was created just over 2 years ago to help build resilience in business communities, whether they be communities defined by geography or special interest. And for those of you who viewed the opening video, I hope you gained a brief insight on our organisation. Since its inception, we've encouraged a wide range of major companies to join us as champions, as well as a host of affiliated organisations and members to our network, all willing to spread the word of resilience through best practice and learnings. And in that vein, and working with Intel, we've created a series of tech webinars that are aimed at exploring and showcasing the best of products and services that can help organisations to recover from the effects of COVID. The series features presentations from a range of companies in the rail, retail, cargo and energy sectors. And today, the last in the series, we are greatly looking forward to this energy and power series sector. In all the sectors, we are increasing the reliance on technology through the recovery of COVID, and whether that be remote sensing, automatic ticketing, storage utilization or energy conservation, tech solutions, and help offset the disruption caused by the pandemic. Today we're looking at the energy and power sector and have an excellent panel of speakers to listen to. Your chairman for this morning is Ian Butcher, who is the Oil and Gas, Energy and Water Utilities Account Executive at Intel. I invite all of you to ask questions of the speakers throughout the session by posting your short written questions in the chat box to the right of your screen. I'm sure the chair will pick as many as he can as we progress through the webinar. I should add that all the speakers' bios are in your joining instructions, so I hope you look at those before the speaker begins. I will now hand over to Ian, who will introduce the topic and the speakers. Ian, the virtual floor is all yours.
Thanks, Robert. Much appreciated. So, as Robert mentioned, I'm responsible for the oil and gas, energy and water utilities industry at Intel in the UK, and I've had the pleasure of working with Resilience First for the past sort of 18 months and talking to businesses about the various resilience challenges that they face. I think if we look back over the last few years, our infrastructure has been put to the test. We've seen the beast from the east causing widespread disruption with lowest temperatures of minus 14 degrees. Then we saw the country battered by torrential rain, and we saw flooding across parts of Yorkshire and South Wales, measuring up to a metre in a very short period of time. We then saw record temperatures of 37 degrees. And I remember being on the tube when that was unbearable in London, and then also having melting railway tracks as well. And then we've had 1 million people in the country, across the country, without power when we had 2 power stations fail. And then add to that, this year we're tackling what is COVID pandemic and forcing the majority of people to work from home for a period of time. So we really have been tested as we've been through this. And I think one thing that we agree on is that the energy grid is resilient, it's held up, we've got the right mechanisms in place, and I think as we go forward to build a system of affordable clean energy infrastructure and that is required to safeguard the future economic security, we need to modernize and take advantage of digital technology and developing smart grids that are more responsive to deliver clean energy and higher energy savings. So with that in mind, we've got some fascinating, as Robert mentioned, fascinating people to talk to. So first off, we're going to hand over to Brian Fegan from Balfour Beatty. So Brian is the construction manager working on Hinkley Point, and then we'll have a Q&A session after that, and then we'll move into 3 technology updates where we'll hear from Philippe, who is Vice President Energy Utilities in the chemical sector at Capgemini. We will have Carroll, who's the founder of Episensor, who you effectively build sensor technology and have IoT platforms to provide solutions in that space. And then we will move on to Jordan Appleson, who from Hark Technology, he's the CEO there, again, looking at IoT connectivity in the energy space and how we can benefit from that. So it should be a good, engaging conversation. Have plenty of time to ask questions. If you have questions, please put them into the chat box, as Robert mentioned, and I'll do my best to sort of filter through those and get those answered by the audience. So with that, let's hand over to Brian, and Brian can talk more about what he's been working on and how technology's been working to build complex structures, but also talk a little bit about how they've been engaging and working through with COVID in mind.
Brilliant. Thank you for that introduction. And firstly, I want to say thank you very much for letting me speak and to talk to you about some of the work that I've been doing with Balfour Beatty. So the theme of the day and the kind of the theme of the week is obviously the resilience, bouncing back from COVID, but also using new technology to help us improve, to be more efficient. And really what I was going to talk to you all about this morning was how myself and my team here is working to build new energy and power. We're working on the new nuclear build, the Hinkley Point C project currently, and what we're doing with technology to help us build these new complex structures. That's something which is maybe unique to what we're doing, but it's something which is a transferable technology, transferable skill, and I think is really valuable. I would tell you for free that I was not the first advocate of technology before we started on this journey, but now I just see that we can move on with leaps and bounds through use of new technology and employing it in new and clever ways, and using young and talented people to do that for us. So I'm going to talk to you for the next 10 to 15 minutes. Ian, please do shut me down if I'm talking too long. This is a presentation that I like to deliver to you. I can't take all credit for all of the information into it because I have a very strong team of engineers that work for me at Balfour Beatty, and they have helped build this presentation and actually to deliver it day to day on site. So firstly, thank you to them, and that's been helped by my agent Johnny Gray, Matt Fowler and Lizzie Wells, who are three brilliant engineers, if you ever come across them. So you've read my bio, you know a little bit about myself. I'm Brian Fegan. I am the construction manager for Balfour Beatty, based in Somerset, and we are building a large part of Hinkley Point C. Hinkley Point C, if you don't know, is two new European pressure reactors, which will be producing energy for around a fifth of the UK, approximately, which will provide a source of new, clean, reliable energy for future generations. And this is something that we want to get right. We want to make sure it does stand the test of time, and we want to build it to the highest quality standards. And they are the highest quality standards I've ever seen on any job, and it is something we're really striving to deliver the best of the best. So the image you see here is a bit of a glimpse into what we're building. The structures are actually part of the cooling water system, which provides the cooling water from the Bristol Channel to the reactor, and the water will go and turn to steam and also turn the turbines to generate the electricity. So we are, Balfour Beatty, are drilling tunnels underneath the estuary at the minute, and then we connect the tunnels into the seabed. And there's a structure called a head, which you just see in the very, very center on the green barge. That is being built by myself and my team. And next year we will install these on the Bristol, in the Bristol Channel, approximately 30 nautical miles from where I'm based at the minute. We will transfer them by barge and lift them in with these two large offshore heavy lift vessels. So it's quite an interesting bit of work. So the agenda, I'll try and rattle through this because it's a very interesting topic and could go on for a while, but talking to you really about the challenges. We wanted to adopt a more digital approach, go paperless. We've got highly complex challenge here, lots of individual components, lots of change, very large workforce who are quite of the older generation and may not necessarily have been tech savvy. So that was a question. And we've also got the challenge of COVID and the new normal. So I'll talk to you about a bit of the project background, how we've gone paperless with our quality assurance system, how we've used 3D models and technology to allow us to build this product. Lots of collaboration involved in there, and then some new interesting bits of technology and how we've managed to apply them. So background, head construction. I just mentioned these quickly, but just to give you an insight into them, the structure on the left of the screen is called an intake head. That's about 45 meters long, about 9 meters high. That weighs approximately 4,800 tons. The one to the right is a bit smaller. It's the baby brother. That is 16 meters square, about 9 meters high again. That weighs approximately 3,300 tons. So we just have the simple task of building these in the docks in a facility, and then just picking them up and moving them 30 nautical miles and landing them precisely in position offshore in the Bristol Channel. So easy peasy, there you go. That's what we're here for. So ultimately the head will sit on the seabed and the shaft will be drilled through and connect into the tunnel, which is being dug at the minute underneath the channel by a tunnel boring machine. And that will provide the source of water to generate the power in the nuclear facility. And I like to tell everyone that it's the most important piece of the whole puzzle, because you can spend all the money getting everything right onshore, but if you don't get any water to it, you can't generate electricity. So I've got the most important job. There we go. What we did at the very start of the job, we had a look through the large amount of information we were given by the client. There was something like 800 drawings for different elements of the work. All of them have got lots of squiggly lines on, like you see there. But what that information is telling us is it's the old-fashioned way of telling us how to build the structure. And really, from that drawing, we looked at it and was like, that looks difficult, but we can't quite picture what that is and how you build that. So straight away, we were having some concerns and some doubts that the information we were given to us would allow us to even build the project to the desired specification. So we went on a bit of a learning curve ourselves and employed some specialist companies to provide this information in a 3D format, producing a 3D model, which allowed us to visualize the problem at hand. It also allowed us to understand that these structures, the intake heads and the outflow heads, individually made up of over 120,000 different components, which when pieced together all clashed with each other in up to, I think, 20,000 locations on the outfall and around 50,000 locations on the intake. So in effect, every bit of metal you lay down would clash with another bit of metal. So we decided we'd had to redesign the whole thing in a 3D format, which would declash the structure and allow it to be buildable. So we produced this model of all the reinforcement, and it is what is called a fully clash detected model. All of the different colors, there's so many of them here, are actually individual bars, and when you manipulate and zoom into the model, you can identify the bars, identify the unique information to do with that bar, and it tells you where it should be placed in the real world. So that is invaluable information. It is the first thing we did, which really helped us overcome the biggest challenge, which was making something unbuildable buildable. So the 3D model has been produced. That's declashed everything. That's allowed us to make something buildable. We then produced a set of 2D drawings from the model. So we produced some new 2D drawings which were more accurate and fully reflected a buildable job. This was so that the less tech savvy people, the older generation, actually had an opportunity to build the job, they were not too au fait with working from iPads and tablets. They wanted the more paper-based, but the model is there, and it's allowed us as a reference tool to help understand and visualize difficult parts of the job. And we actually have got big TVs on site, and all of the engineers and supervisors have tablets on site, and they have the model with them. So when all the drawings are laid out on the table and you can't visualize something, they just take the model, put it on the screen, and brief all of the workforce and actually show them what it's going to look like when it's built. And that is really very useful. We have also made our quality assurance system go paperless. And if I just show you a bit of a picture of what a normal office would look like, with hundreds and hundreds of bits of paper stacked up on desks, which can quite easily be lost, we have turned this into, well, it's disappeared. That is non-existent now. That is archaic. What we use is a software called Spartan, and it's been developed bespoke for this job, but it's a market available software which is tailored for each project. And we've used that to allow us to produce all of the same bits of paper in the same format. They all look the same, but it's all done on a tablet. And then it all uploads to an online database, and it allows us to collate the lifetime records, and we don't lose things. That's the best thing about it. It's a lot slicker, and also you don't have to pay for loads of reams of paper. So 3D modeling and design. We didn't just get to this stage through sending out an inquiry and coming back with all the answers. It was a very collaborative input throughout the course of a number of months. So we worked with a design company, we worked with our client to understand their needs, and we worked with a specialist contractor who would be undertaking some of the works on site. How would you like to build it? In what sequence would you like to build it? Which is the safest way? So we did this together. We did lots of virtual calls. We had designers working in India and Australia and Glasgow. We had contractors based in London, and we're obviously based in Somerset, but we have an office in Bristol, an office in Avonmouth, an office in Hinkley Point as well. So we were already spread across multiple locations, already used to weekly calls over Zoom and different webinar platforms. So we're already used to talking with each other and collaborating across continents to solve a problem. And this combined effort helped us resolve the problem at hand and come up with that output that I've already showed you. So there's lots of the technical difficulties, establishing model setups, file types, breaking down work into elements. It was quite a lengthy process, but we've learned a lot from it. And what this did, it avoided large quantity of FCRs. FCR for us is some jargon that we use, but it's basically a field change. Every time you're building something and you come across a change, that's a delay, that's a cost. So by spending this money up front, we've really avoided delays to our program on site, and it has allowed us to successfully deliver large elements of the work to program and to a budget that we all believe in as well. So on site, how does this all work? How does it come into reality? So we've already said that the 3D model, that's been reviewed up front with the supervisors. We've already established how we're going to build the job, and that's how we've designed it. From this, we can plan works most effectively. We can produce a program, and we can stand by it, and we can say over the next few weeks, we're going to build this floor slab, this wall, and this roof in this sequence. So lots of desktop studies are produced, visualizations, fly-throughs, 4D simulations, and also paper-based, what we call like flick books, where you can almost flick through and like you're building a Lego model or some kind of airfix set, you can see step by step where you put this part. Part 1 goes next to part 2, part 3 goes next to part 4. And I've never seen that before in any job, and it's very, very useful. And as I've mentioned earlier on, The supervisors on site have the tablets for visual aids, and we have site cabins with TVs so you can see the model as well. This is just a bit of an example of a bit of a flick book here. So we've cut down the 43 steps into 8 steps, but this is a very complex bit of the works, and you might not really be able to see it too well on the screen, but there is hundreds of thousands of individual bars which all have to be pieced together here. And the pink elements are rebar, reinforcement. Then there's some blue circular rings that have to go in. There's some more pink bars. Then there's a large yellow cylinder that gets dropped in, and a large yellow lifting point. This operation would have taken a number of weeks, but we got this down to a number of days after using this flick book to kind of explain it to the workforce. So we've kind of covered some of this point previously, but one of the key things to pick up is it's critical to have some tech-savvy people who understand the benefits of using this model and understanding the possibilities and where it can go, and also to control it and control the distribution so people don't edit it, play around with it, or break it. The quality control side of things, which I've mentioned as well, we are using the digital quality assurance system, which really there's got a bit of a step-by-step here, but this produces a suite of online database of all of our quality records, and from that we were able to produce an as-built of the model, and then like a 3D as-built of what has been built, which can then be updated and supplied to the client. So this is how they as-built it, and it's kind of a step-by-step. You can literally go onto the model. Once it's pink, that's what's going to be installed. You highlight everything in green, that's what you've installed, and then the model is updated and it's saved, and that's green, and that's how it's installed. And then you can actually go through and check that there's nothing missing. This is very important when you've got 100-odd thousand individual components, because if every time you install something, you literally click it on the model, it turns green, you save it, you know you've installed everything. This ensures for us that we're not leaving any latent defects in the structure, which is very important for a nuclear project. We're not missing anything out, and we're not putting anything else in that shouldn't be there. So it's very, very useful tool for us. And once you're on the model, you can click onto the element that you've installed, and it will reference the quality check sheet from which you've signed it off on site. So this is another way of us to show a full golden thread of the bars being delivered, installed, checked, and then as built. And this is very useful on a nuclear job, which is very hot on quality assurance and record keeping. So some further innovations. What we've found is we've had a 3D model which is in effect a dumb model. It doesn't move, it doesn't fly around, it doesn't have any simulations to it. But by using that in conjunction with other readily available products on the market like Synchro and Fuser, we can add some life to it, and we can also use it as a planning tool. So here we've got an example where we've added all of the temporary works, which is all of the formwork. In this case, it's all yellow. You can see large back propping, and you can kind of see that all of these yellow props clash with these orange areas, and they clash with some access and some walkways. And this was flagged up on a 4D simulation 4 weeks ahead of us actually carrying out the works on site. So we realized we needed to adapt all of the temporary work so it didn't clash with our walkways, with our landing loading bays, and with other fixed items on site. So this allowed us to do upfront planning to avoid clashes, which would ultimately have arisen on site and could have led to downtime and delays and to cost overruns. So that's just like a very simple visualization to explain that. We have also had some areas where there's been tricky access requirements. We obviously have to consider the health and safety of the workforce, and in some areas we were wondering how we'd get in to fix certain elements of the work. So what we did a lot of desk studies with 4D simulations to understand how could a person fit in there. Could it be done beforehand, so they don't need to go in there? We tried to run our program in a number of scenarios before building it on site, to avoid clashes, to avoid delays, and importantly, to keep people safe at all times. And it's really valuable for that. This is another example as well, but one of the key things, just to kind of to wrap up here, is we've also been able to use the 3D model and work with ground-based scanning equipment and also drone-based scanning equipment to do some remote verification of what we've built. So ground-based scanning is readily available from a number of different products on the market. That can scan the reinforcement or what you've built to a very high accuracy, which can then be verified against what you've got on the model and can remove people from working on site. That itself is valuable for when we're considering the COVID situation. We've already had the ability to have engineers working from home, not being able to have to come to site just to check measurements, because we've already got a laser scan which can be done with drone and can be done remotely. So that itself is a new innovation for us, which we're working on, and I think it's the future. I'll just go through to the summary, and really this is just the last slide here. So just to sum up, the 3D model is an extremely powerful tool. It's got very a number of benefits there. We've found the outputs from it can be used by non-tech savvy people, but they do still like a 2D drawing to go with it. So having some young, keen and tech savvy individuals and giving them the trust is very, very, very useful, because they will actually go out, use the model, explain it to the older generation and make things happen. Digital QA, highly recommended. Couldn't be an advocate for it enough. Saves a lot of time, a lot of money. 4D modeling is proved very useful. We are still rolling it out in briefings, but we're trying to take it further and to fully program everything using it to save us a lot of time and money. And there's great potential in using ground-based and aerial-based scanning technology to verify what has been built remotely, avoiding the need for engineers and staff to be based on site, which particularly is of interest in the current new normal we have here. That for me is it, and I think I'm about up in terms of time now as well. Hopefully I've covered everything, and if there's any questions, great to hear them.
Yeah, it's fascinating, and I like the idea of Lego in building something so grand as this. I think it really helps to sort of to visualize. You have this manual to sort of build it block by block. So I think there's a couple of questions that have come in. So that we've got here. So the first one then. So what's your number one learning so far on this project?
That's a tough one. I think we've learned an awful lot, to be honest. The biggest thing for me is you need a 3D design which is fully clash detected for something as complex as this, and that could be a reinforced concrete structure like we have here, or any type of building with lots of interfaces, because without that we would have not been able to build this structure. With that, we've now been able to prove that it can be built. That's definitely the biggest learning for me.
And I guess there's a cost element to this as well. Obviously, the process time, the amount of paper that you had there in terms of doing that. Some of the questions that are coming in. Do you have a kind of a fixed understanding of what sort of cost savings you've been able to get from this?
I would say the cost is more so in the potential for delays that you could have if you don't have the paperwork. We're working in the nuclear industry, but any industry nowadays, you have to have sufficient paperwork to back up what you've built. If we spent a couple of £100,000 by getting a new paperwork system in place, that would save potential hundreds of millions of pounds of having to build a project again if you didn't have the paperwork in place. And just one missing bit of paper with one missing signature could stop the structure from being handed over to the client at the end. So really it's the risk of getting it wrong, and I think that outweighs any cost up front.
Great. Well, thank you for that. Very interesting. And what we're going to do now is we're going to build on this a little bit, and we're going to bring in Philippe from Capgemini. So he's going to talk a little bit about what as a global a GSI, effective solution integrator, how Capgemini can take this and build on that as well. So Philippe, I'd like to introduce you.
Thank you, and good morning, everyone. So I am Philippe. I'm leading energy, utilities, and chemicals for Capgemini, which means 24,000 people all over the globe. We have, during this hectic time, monitors what's happening on the sector and what can be the help of the technologies to transition to the new normal and to respond to the crisis. First of all, in terms of the impact of the pandemic, we all know that it has provoked a global slowdown in the economy, a global decrease in GDP, and definitely it comes from the reduced mobility, the slowed industrial production, and the reduced oil, gas, electricity, and other carriers consumption. Of course, teleworking has developed. Our clients in energy and utilities have definitely proven their resiliency and the fact that they were able to sustain the economy with energy during these hectic times. On energy transition, the impact has been fantastic, probably a 9% reduction of greenhouse gas emissions this year. But it's a non-structural, it's a conjunctural fact. With also investment slowdown, with the share of renewable, which has been for the first time in Europe larger than the share of fossil fuel electricity generation. And on energy transition, we should also mention that the recovery plans will reinforce this kind of project and trajectory. Transitioning to the new normal means, of course, new travel policies, new teleworking policies for our clients. Teleworking means technology, of course, means greater price volatility. We have seen very, very volatile prices on wholesale market for electricity and gas, and a crash on the oil prices. All the players are rethinking their strategies, their position on the value chain, and their geographical position. I will come back on digitization in a moment. They have all to consider the assets that they will operate, and there will be a lot of M&A happening. Some players will sell some assets to concentrate on some markets, and finally will get a new position from buying asset on operations from other players. And it requires agility, and that's where technology could also bring solutions. On the oil and gas, I would like to mention that diversification, we are at the oil peak, definitely, most in the developed countries, and the players are moving to a new battlefield, which will be for European renewable storage, hydrogen, and EV mobility, for example. And for some other players in other countries, it will be concentrating in other assets management. So, transitioning to the new normal, M&A opportunities, revisit your strategy, account for more price volatility and being more agile, but also reducing your costs. And a lot of OPEX and CAPEX program has been launched, including some cash protection projects. And for that, definitely the technology can help. We have seen an acceleration of digitization for the oil and gas players, mostly to get OPEX reduction, which has not been the case for utilities. Utilities were very, very fast movers on digitization these years, and they have confirmed their trajectories, sometimes revisit their trajectories to select the most appropriate project to mitigate the risk of the pandemic and to mitigate the transition to the new normal, to face the transition to the new normal. They have all improved their cybersecurity because they have faced to a larger number of attacks, and some of them have been successful, unfortunately. So they have improved their cybersecurity play. In terms of technologies and the future of energy, of course, the customer will change his behavior, will ask for green energy, will get new usages, electric mobility, hydrogen solutions. But the revolution, when we consider the transition to the new normal, but when we consider also the future of energy in 2040, 2050, the technology evolution will come from, on one side, the deep technologies, meaning renewables, carbon capture, utilization and storage, new nuclear solutions, not only EPR, but also SMR, thorium, and other nuclear solutions, storage, flexibility, and smart grids, hydrogen, mobility, and perhaps tomorrow, superconductivity, which is not ready today, but which can come. And on the other side, you have all the digital technologies, IoT, cloud, software as a service, artificial intelligence, robotic process automation, intelligent automation. We don't see any technologies that will break through and change completely the game. We see the fact that this will be a combination of deep and digital technologies that will change the game tomorrow. A combination. Let's take some example. A hybrid farm, which is a renewable farms combining wind, solar, storage, and energy management. Let's consider smart grid, in which you can have solutions like substation automation, substation virtualization, and we see all the grids going at scale today after years of experiments, because the technologies are ready to go at scale, and because also we need this kind of technology to host more renewables shares, to host new usages like EV, and definitely to have a strategy of convergence between energy carriers. So we see this, and we see also a shift on as a service model. We see that the customers will not buy electrons or cubic meters of gas. They will buy a final use, charging, lighting, heating, driving, and things like that. So no deep technology disruption, but a combination of deep technologies progress and digital technology levers. This is very, very important. And finally, I will try to emphasize the data-enabled services that will also bring a lot of progress. The green recovery packages will accelerate this move. That's
excellent. So, Philippe, fascinating, and I think now this is going to be complemented, because as we pass over to Gary. So, Gary, you can talk a little bit about, from the IoT right at the edge, the very sensors as well, how you generate that data in the first place. So, if you want to sort of do a little bit of an introduction there, and then we'll come back and we'll talk lots of questions. So, I'll come back and talk about this shortly.
Very good. I hope you can hear me. And first of all, thank you for inviting me to be part of this. I'm Gary Carroll. I'm the founder of Episensor, and it'll be a challenge to talk about Episensor in 5 minutes, but let's see what we can do. So Episensor provides industrial automation using wireless Internet of Things, industrial Internet of Things platform. And much more difficult than actually designing the products when the company began. Finding our position and how we deliver value to our end customers was a huge challenge. So we realized that for the past 40 years, major automation companies that we all know well, the global giants in this area, such as Honeywell and Siemens and Schneider and Emerson and so on, they've actually done a fantastic job. and they've actually set the gold standard for how this should happen in terms of accuracy, ruggedness, reliability, security, and large-scale deployment. And when you move to industrial IoT, it's very important to say that you're not making a compromise, that you're not actually losing some of what has been available, whereas you might be gaining some flexibility and so on. So we've taken the approach that the gold standard that's set by these companies over the last 40 years is our starting point, and that you should lose nothing but gain from a different approach. So in a sense, we're not doing anything new from a technology point of view. We're still measuring the same things and so on. However, we're making it easier, much, much easier than the traditional approach to deliver sensor data directly to the cloud. And that means that our partners can actually focus on building the solutions. So we think that industrial IoT is a user experience revolution, not necessarily a technology revolution. Okay, so this leads to our architecture. And the architecture, first of all, from left to right, goes from raw data, which is practically worthless, to a valuable insight where you can take an action and where you can actually release value from a system. We start with our hardened devices out there in the field, beyond the edge, as the IT people would call it. Then we go to a gateway, which uses Intel technology. It's delivered by Dell, and we go to the cloud, and eventually an insight is actually generated. So the gateway, with a focus on the gateway, it has communications technology. It is a full computer platform in its own right, and it's actually a compute platform that can be used by our clients as well as ourselves to actually deliver a solution. And then we have a plethora of what we call battle-hardened wireless devices, which we can deploy very flexibly and very easily. And in the context of COVID, we discovered, first of all, that the Far East and Taiwan and Singapore and so on were some of the first to recover, and actually it generated very considerable business for us. Also, we have a number of clients where they self-install the equipment, and those contracts would not have been won by us but for the presence of the virus. Okay, so to give you some customer examples as to see what our partners are building. So energy management, energy being probably the largest industry in the world, is an important place for us to play, and it has changed quite dramatically in the last decade. But nevertheless, we've got a full range of devices for measuring electricity, gas, other utilities. We can include water and heat flow in terms of energy, and bring those to a gateway and bring it to the cloud for a full insight. Heat production and heat consumption and the charging for it is another very important place. The refrigeration monitoring. Refrigeration accounts for about 65% of the total energy costs, say, of a supermarket. So it turns out to be a really big load. Production monitoring is something that's very interesting, and you wouldn't expect IoT to play, but we have a number of very large opportunities in this particular area. And then precision agriculture. The photograph there shows the production of berries in California, where they're taken in on a warm day and actually cooled to a particular formula. Demand response is something in the energy area where we actually can shed load or bring in standby generation or batteries to complement the grid. And this is a huge area of growth for us, and we believe we're the world leaders in this, delivering it literally all over the world, with the biggest virtual power station in a number of locations and a number of significant announcements. For example, Dublin Airport can move to standby generation, using our boxes to completely go off grid. With partners in this, with the Air Grid in Ireland or the National Grid in the UK and so on. That's a look at the particular box that we use, and we think this box is replacing something between 10 and 15,000 pounds of equipment down to a couple of thousand pounds. So we're actually revolutionizing this whole area. So if you have large installations, new things happen. First of all, you can use the same platform to actually layer one application on top of another, and that's where huge value is actually released. And an IoT system allows you to do that. Then when the number of installations gets really large, you get a second wave of data, not the data that you're interested in terms of temperature and humidity, but actually metadata for all the bits and pieces of hardware that are out there. And so when you reach a certain scale, device management becomes really important. And so we've introduced a device management platform called Episensor Core and Episensor Edge, which allows you to do this right out to mobile devices to allow commissioning remotely in any part of the world. And this will allow something that we might call in the future courier install, where somebody with no knowledge can install a completely new system. So
Hey,
I leave it
Gary.
at that, and thank you very much.
Thank you very much, Gary. Very, very interesting. And what I'll do is, as you talked about visualizing the data as well, so let's make sure we get Jordan up on screen and let him talk about how visualizing the data and what they're doing at Hark.
Thank you again.
Thanks, guys. Really appreciate the opportunity to be here today to talk a little bit about what we do and some of the solutions. Essentially, we are deploying for customers. So a bit of background about Hark. We're an energy analytics industrial IoT company specializing in helping businesses connect, monitor, store, and analyze data from all these different assets. So we go in and we connect to industrial systems, PLCs, existing infrastructure, BMSs for companies, in order to kind of gain insight and automatically control these assets. So in terms of the kinds of solutions that we're seeing, and especially over the last 6 months, how this kind of technology is helping, because essentially people are now remote more often than not now, having kind of remote visibility as well as control capability on core assets is becoming extremely important. And actually, for this supermarket here in the retail space, this is something that has really helped them, especially deliver kind of that service to their end customers in their supermarkets as the world has kind of changed. For instance, with this particular supermarket, they're a top 4 supermarket in the UK. We monitor something like 24,000 assets in real time, and that's real-time energy, data about their buildings. It could be their bakery ovens, their refrigeration systems, their lights, solar panels. And we do all sorts of stuff with that in terms of forecasting, anomaly detection, and analytics. And what was actually really interesting about our solution, this has been in for a couple of years now, and has, I think between 2019 and 2020, saved about £1 million worth of energy spend. Not only that, we were able to connect to all the legacy assets in all these stores. But over the course of something like COVID, where everyone's remote, but also the store times have been changing, right? The building's use has changed quite significantly and quite dynamically over the course of the last kind of few months, i.e. store opening times have changed. There was an extra hour here for kind of NHS and key workers, for instance. That means that all these buildings have had kind of rapid changes to the profiles. For instance, what assets need to be used, lights, and energy as well. And, in a typical circumstance, that might have just been, right, turn on the lights 100%, right, as an example, or turn everything up to full over the course of this period, just so we can make sure everything happens correctly and people can get into the store and it can be used slightly differently from the norm. Our platform has automated all of that. So as soon as things like opening times have changed automatically in their primary systems, our system's updated and it tells the building what it needs to do, for instance. And that has not only optimized the building, the assets, instead of kind of maybe being wasteful here, it's also allowed it's also saved a lot of time and a lot of energy from all these business people in the business who are supporting this, working from home remotely. Not only that, it highlights different anomalies with stores, people maybe changing assets manually, and that that can always go down a little bit. It can always go down well when people leave things on for too long and it uses a huge amount of energy. And I suppose with this as well, there's actually a lot more on this case study on our website. There's a 2 or 3 page PDF. So, welcome everyone to kind of head over to our website, harksys.com, and download it. It's full of detail. One of the other things I'd probably talk about as well is kind of the idea of the smart building. So, in terms of the energy space, we monitor and control energy storage systems. This is a relatively small Tesla battery. It's about 240 kVA. That it takes a large building off grid, and also is used by a utility to kind of trade out the battery when it's required. And what we saw with buildings like this, especially with these assets, is a significant drop off in energy over COVID, as you can imagine, right? No one's going into the buildings. That's kind of an 80% reduction in power. Why it's still using significant amount of power is the reason why we exist. Is that we know the profiles, we predict the profiles of the building on a daily basis. Utilizing that information, we typically inform when the best charge times to charge are, when the best times to discharge are. But also that is then hooked into, say, a utility that can then kind of request dispatch when required. Now, since COVID, obviously that whole area, not just with this energy storage appliance, this battery here, is super important, because what we now have is a complete shift in the profile of the building, and actually the way this asset is operated, it needs to change almost in near real time. And that's something that our system does. Now, it's not just the battery, but it's also the building. We're hooked into things like the BMS system, so we can actually alter the profile of the building to suit things like the charge cycles of the battery, as long as we've got all of this connected. And this is all about the analytical capabilities, control capabilities, using things like machine learning. And what that ultimately means really is that as things like crises like the COVID happen, and hopefully this will be once in 100-year event, but that's not the only kind of event that we need resilience for around. It might be the energy sector, it might be utilities, it might be infrastructure, and utilizing data, real-time data, streaming it out and combining it for then automated control is almost a nirvana to be able to hedge and mitigate risk. Now, obviously there are things to consider like cybersecurity and cloud technology and how you utilize that, but ultimately the nirvana is to not just monitor the data and turn it into insight, but then drive automated action in order to kind of get the best return, increase efficiency, reduce waste. And that's ultimately really, really important. Now, I'm happy to take any questions about this. And like I said, there's some information on our website, so I'd encourage anyone to go and have a look. But thank you very much for having me, and Ian, over to you.
Perfect. Thank you, Jordan. Much appreciated, and to Gary and to Philippe as well. So as Jordan mentioned, if you have questions, please do enter them into the chat box, and then we'll do our best to get them answered in the next sort of 5-10 minutes or so. So I suppose that what we've seen here is, we had Brian talking about the build process and how they were adapting to have effectively inspections being able to be done from home. We've seen, Jordan, you talked about there about, or Gary actually talked about the sensor data and enabling that the data to be generated, and then you've got ability to actually access that data and manipulate that data from home as well, which is a really interesting space. And as we all moved home, how are we seeing this kind of the cyber attacks landscape? We kind of touched on it, most of you touched on it, but how are we actually seeing that in terms of accessing to that data from home?
I mean, that's a really, really good question. I think it falls into almost two or three categories, really, especially from our side. There are companies that are already geared up for that remote working and security from the ground up, and then there are slightly older businesses that have been around a lot longer that maybe aren't accustomed to the remote working, and there's been a massive take up of kind of that digital shift right over to remote working and security. I think I was reading something where something that a rather large, I think it might be an insurance company, thought would take 12 months to get everyone working remote, took like 4 days when everyone came together. But when it comes to cybersecurity, I think it's a really interesting point, because we as a business, we maintain a very high level of cybersecurity regardless. But if you look at things that are going on in the world from a cybersecurity point of view, you see life sciences companies at the moment being targeted by, in the news for information on, biotechnology and all that kind of stuff. And I think it's it's never finished, right? You have to be continuously monitoring and updating security technology policies, and that's why that as a service model that Philippe was talking about is kind of really important, because actually what you really want to do is buy that security as a service, rather than it's one time, it's another time, it's another time.
We have seen an increase of attacks during the lockdown and the remote working of 20 to 30%. And when we are speaking of it, the baseline, for example, for a retailer or for a distributor, is something like hundreds of attacks every week, and it increased 20 to 30%.
I would just like to comment that traditional automation systems sometimes didn't take account of security from the beginning, and so if you had access to a pair of wires on any particular site, you had an access in plain text to an awful lot of data. But the more modern, even the wireless systems that we're developing, have security built in from day one, and they're actually far more secure than the traditional automation systems. we tend to comply with the requirements of an IT department, whether that is to lock the data outside the corporate network completely, which we can do, or to lock the data inside the corporate network and comply fully with the demands of the pharmaceutical industry or the of Intel and large players like that and banks and so on. And we've been successful on all of those kind of sites. So it was built in there from day one.
I think this is the follow-on question to that which has come in, which is a good one in terms of, and I think it's on the top of minds of lots of CEOs around this. Is as we kind of build out our 5G and IoT platforms and offerings, how do we deal with privacy issues? Because these devices are going to be everywhere. So perhaps, do you want to start with that?
Yeah, no, it's a great question. I mean, ultimately, when it comes to privacy, there are different layers of privacy. I think when you're starting with any project, obviously, Gary mentioned things like the gateways, having hardware encryption at the edge, for instance, as an end-to-end encryption. These are all just the basic tick boxes. But then you have to think about, well, where do you store the data and what type of data do you have? We're working with technology at the moment where we're doing a lot of processing on the edge now, and we only emit anonymous metadata up to the cloud, and that way that data doesn't actually leave the site, but the insight for the metadata that generates the insight for automation, long-term and inferring a strategy, that's the thing that's sent up. And when it comes to personal data versus sensor data, they're two different ball games, really. You've got this GDPR element of what kind of data are you storing, whether it's customer information or it's personally identifiable information, whatever that might be. And then you also have this IoT data as well, which is very much ones and zeros and numbers, right? And what are the associated risks with those two different types of data, essentially. So when it comes to everything, end-to-end encryption at rest, making sure that things are pen tested, and there's an ongoing weekly, if not daily, automated testing around security. That's something that we do here. That's really pivotal in mitigating, or at least identifying risks that need mitigating quickly. Yeah.
Great. And I think there's one that's going to change tack slightly. There's one question which I'm going to aim at Philippe here, but it's more of a case of almost like a ground zero. Effectively, we lose power. We're out for greater than 7 days. We've got no water, no cash, no internet. How resilient are we, and what can we do in that space to survive, I suppose?
Very good question. In fact, all the developed countries had been very resilient. No, even with more attacks, cyber attacks, we have been very resilient, and we have sustained as a sector the economy. The economy, thanks to technology, working from home, both on customer service and on operations. We have been definitely resilient, even if the crisis has been terrible, not only for utilities, but also for oil and gas, where we had, in fact, two crises, the pandemic and the collapse of the crude oil prices.
Yeah, absolutely, and I think that probably actually brings us. We're kind of reaching the top of the hour, just to sort of to close out. So I think, firstly, I thank all of you for your time and your presentations. Hugely interesting, and just showing the kind of the in the coal face actually developing in this, and how digitization is really helping to build. I might go back to my Lego analogy, but having the Lego there that you can build using digital twins effectively and find out some of those challenges ahead of time really does help to smooth things over as you work on these huge installations. And I think technology that we've seen provided by the three companies here is also really talks about the future and getting useful insights from that data that can be used to drive better business decisions. And I think that's a key going forward. So, and particularly in the energy market as we look for modernization. Robert, I'd like to hand back to you and so we can close out the rest of this session.
Thank you, Ian. Well, it has been a fascinating hour, and we've covered a lot of ground. On behalf of Resilience First and Intel, I'd like to thank you all, and particularly the speakers and the chair, for their excellent contributions today. We will be circulating a short summary in due course. So all it leaves me is to thank you all. Have a very nice weekend, and goodbye.
Thank you.
Goodbye.
Thank you.